In this video, we're going to talk about solving systems of linear equations in 3 variables. And one of the things we can do is we can use the idea of elimination and substitution very easily, but we have to be very methodical in the way we do it. The first goal that we're going to make sure we do is to find 2 ways to eliminate the same variable. And this is the most important idea, because what happens a lot is when we're looking at an equation like this, people will look at this and say, oh, I can add these 2 together. Excuse me, I can add this one and this one together, and that will eliminate my y, but then I can add this one and this one together, and that will eliminate my x. But that doesn't do us any good, because then we'll have 2 different variables, 2 different equations that will have different variables missing. So what we're going to do is we're going to find this 2 ways of eliminating the same one variable. So for this first problem, what I've decided is I'm going to find 2 different ways to eliminate x. And I'm going to start labeling these as equation 1, equation 2, and equation 3. And what I notice is that I can combine equation 1 and equation 3, in order to eliminate x. We have the coefficient of x is 1, this is -1. So I'm going to write these all out. And I'm going to add these down. Remember that when we do this, the addition or the elimination method, we don't change this in any signs once we've got these set up. So x and a -x cancel out or become 0x. Then I have 6y minus 4z is equal to 2. So I've got one new equation, and I'm going to call this equation 4. This is just my organizational way of doing things. So the next thing I'm going to do is I'm going to find another way to eliminate x, and I'm going to focus on equation 2 and equation 3. And you can do any combinations. I can choose to eliminate y 2 different ways. There's many, many different ways, and I'm just demonstrating one. But when I do this, I notice that 2 I can keep as 2x minus y plus z is equal to 3. But 3, in order to get the coefficient that is the opposite sign, the same value but the opposite sign, I need to multiply this one by 2. So remember, we multiply every single value, or every single term, excuse me, that's a minus. Every single term by 2, not just the 2x. So once we have that, then we're going to add that down again. So this cancels out. I have 9y, I have -5z, and I have 7. And I'm going to call this equation 5. So in doing this now I have 2 equations, equations 4 and 5, that are put into, that have only 2 variables. And now this goes back to what we did in an earlier section. I just have 2 equations that need to eliminate the same variable. So what I decided to do is I was going to eliminate y. So the next thing, and I always put these here, it's a great way to communicate with me too when you're taking a test. What are you doing? So when I'm eliminating y, I notice the greatest common least common multiple, of y coefficients is going to be 18. So that means I'm going to take 4 and I'm going to multiply it by 3. And then I'm going to take equation 5 and I multiply it by 2. But if I multiply this by 3 and this one by 2, they're both going to be a positive 18. So I need to make sure that I multiply 1 by a negative value. So I could have multiplied the top one by 4 by 3 and 5 by -2. But I decided to do it this way. So again, multiplying all of these values, I've got -18y plus 12z equals a -6, and then multiplying equation 5 by 2, I have 18y plus, no I don't, minus 10z equals 14. So adding these down now, I have 2z is equal to 8, which means z is equal to 4. So I've found the first value. When we put it in ordered terms, it's going to be x, y, z. So z is equal to 4. I've got that one worked out. So now I go back to an equation where I have one known and one unknown, so it can be either one of these. So I'm going to pick equation 4. So equation 4 says 6y minus 4z, but now I know that z is 4, is equal to 2. So this works down to y is equal to 3. So that is the second value in my 3 variables. And then I have to go back to equation 1, 2, or 3, where I have one unknown. So I'm going to do x plus y minus z is equal to 0. So that means that x is equal to 1. So that becomes the full the full answer. So make sure you're always finding your x, your y, and your z. Getting down to one of the values is part of the challenge, but you have to get down to the rest on the rest of them. And that's what you want to make sure you remember, is that we have to eliminate the same variable 2 different times. So you can try this out on the next problem, which is right here. So in this one again, I decided to eliminate x. So I'm multiplying equation 1 by -2. And then I'm combining it with equation 1. Let me label these here so I can understand. And so then I'm going to get the first set of equations. So adding these first 1 and 2 together, we add the -2y and the 3y, we get 1y, we get 7z, and that's a -2. So that's going to be equation 4. So what I decided to do the next is combine 2 and 3. So that means 2 needs to be multiplied by a -1, and 3 just needs to be left as itself. So we're going to write this down. We got -2x minus 3y minus z, -6. Everything gets changed on the sign, so I have 2x minus y plus, plus z is equal to -14. And what's kind of cool with this one is both the x's and the z's pop out. So I've got -4y is equal to -20. So y is going to be equal to 5. Well, I don't need to combine anything to eliminate because I actually eliminated both x and z. So then I can put that y back into this equation, and that becomes z is equal to -1. And again, my point is my x, y, and z. It's a -1. And then I can put it back into my first equation where I have x plus y minus 3z is equal to 4. And x becomes -4 with our final answer. So the one thing I want to point out is what happens if we have nonlinear combinations. That will be in the next video.